Hello guys, welcome once more to class online. My name is Tutudami. This is the video where we destroy physics and make it what you can do and what anybody can do, because physics, Jamb Physics, is something that is not difficult. And I tell you, and I mean it, is not difficult. Now let's check out Jamb 2014 Physics, question number 16 to number 20, and we shall be tackling questions on things like expansivity, and questions on things like stress, that's elasticity, and so on. Now, but this video promises to be very, very educative and to help you understand a lot of things in physics. Now, don't forget that if you really learn something from this video and you want to get more content that will better help you understand physics, click on like button. We have loads of content to send to you that will expose you to more, that will open your eyes and help you to know that you can do it. If anybody can do it, you also can do it. And let's go to talk about number 16. A force of 500 Newton is applied to a steel wire of cross-sectional area 0.2 squared. The tensile stress is what? Now, when you hear the word stress, stress has a formula in elasticity, and the formula is super easy. Now, it is just stress has the same formula with pressure. It's just force over area, and that's tensile stress. So now we have stress is therefore force over area, and that is just it. Now what is the force in that question? 500 Newton. And what's the area? 0.2 squared. That should be 0.2 meter squared. I think that is a typo. Now 0.2 meter squared. Now just put the force on the area, and that's just the end. So we have 500, that force, over 0.2, that's area. That will give me that is 2,500 Newton per meter squared. That is the answer. But Jamb and WAEC always prefer that you put your answer in standard form. So to do that, just move from the end here. That means there's a point here at the end of every number. Move the point to the back of the first number. 1, 2, 3. I move 3 times. That will become 2.5 times 10 to the power 3 Newton meter square. And that is the stress, and that means that the answer is option C. Full stop. Easy. Now let's check number 17. From the diagram above, the point that represents the elastic limit is what? Now this is an elasticity question, and what we drew here is a rubber. What you see here is a rubber. Now, if you have a rubber and you are stretching the rubber, and you start stretching, and you really want to break that rubber, and you are stretching and stretching. Now, when you are stretching a rubber, you will stretch to a point that the rubber will say stop stretching. This is the end. That end is called the elastic limit. Okay. Now, and that is where you have it here. If you start stretching this stuff from the beginning, let me use a drawing. I have a drawing. If you start stretching this rubber, this is the rubber you are stretching, elastic. You will get to a point called elastic limit here. This is called the region of elasticity, but this is the limit. That means it is the point when the rubber will react back and say, don't stretch again, I can't go further. And that is called the elastic limit. So it is the maximum point of the upward slope. Okay, that maximum point is the elastic limit, and that means that the answer to that question is R. The answer to that question is just R. That is the limit of the elasticity. That is R. But however, if you keep stretching that rubber beyond the limit, then you will not get to a point where the rubber will start yielding to you. It will start allowing you to stretch as you want, and that's called the yield point. And if you keep stretching and stretching, you will get to the breaking point or the fracture point. And that is, now anything beyond the elastic limit R is called the plastic region. And the rubber is already plastic, that means it is already deformed. So now everything beyond the elastic limit, that is called the plastic region. Okay, and that means I'm saying that from this R to this S is the plastic region, because you have gone beyond the limit of the rubber. And this is an elastic material. It can be a rubber, I can say rubber, or I can say spring. Okay, so now, but from the S, if you go beyond the plastic point and you keep stretching, that rubber will break into two, and that's called the breaking point or the fracture point. And that is what you have here, broken line, anything from the S. And that is just it. The shape looks like M, but the elastic limit is the maximum point of the upward slope, and that is the answer. It is R. on my drawing. It is the R point. Let's take number 18 now. The small droplets of water that form on the glass in early hours of the morning is what? Do you have any idea? When you wake up in the morning and you stretch, oh, it's a new day, and you look outside at the glass of your car, or you look at the window, you will see that there are small water droplets. That's a very simple question, right? Now, is it all, or mist, or dew, or fog? Now, do you know the answer to that question? It's very simple. Now, actually, the answer, let's check it out. Now, we have this now. Dew is the answer. That which forms on the glass in the morning is dew. It's just dew is formed from water, right? It's from the cooling of air. When you cool air, what do you get? You get water. So when the breeze is flowing in the night, when you are sleeping, the breeze flows, and when the breeze flow around, from the atmosphere, as the breeze is flowing, it cools. When it cools, it precipitates, and that precipitation means it will become water and form what? And form dew. So it is by the cooling of the breeze that we get dew. When gases like breeze cool down, it condenses back into water. So dew is formed from the cooling of the hair, and that's what you have on your, because in the night time it is very cold, and when it's very cold, it cools. So now let's see. So this is the answer. The answer is dew. But let's talk about mist. You've seen mist before, right? And you've seen fog before. Mist is like fog. They are the same type. But what causes, how are they formed? They are all formed by water in the air. Now during our time, you will see that mist form on the road. So if you are driving on the highway during Amatan region period, please, you will not be able to see far, because everywhere is foggy, is full of mist happen. Now, however, mist and fog are just almost this, they are just actually the same thing, but their timing are not the same. Mist is known to happen more in the early hours of the morning, but fog can last through the whole day. So what I see, if during Harmattan I can't see far, all the houses are covered by white spots, that is fog. So we see that they are foggy, but that's not mist. Mist only happens in the early hours of the morning. So that's the difference between mist and fog. Fog happens during Harmattan, but mist happens in the early hours of the morning. But however, they are actually the same phenomenon, but their timings might be different. So, but ale means all is not even among the option at all. All means to dry. Now, and that's just it. But dew is the answer to that question. Dew is that which forms in the early hours of the morning. That's the water droplet. Why these ones are water in the air. Mist and dew are like smoke, but they are not smoke. They are formed by water droplets in the air. Massive water in the air forms mist, and that is just it. Now let's check number 19. What is the equivalent of 220 Kelvin in Celsius scale? The standard temperature, this is temperature, right? Anything Kelvin is temperature. But in under gas law, we learned that the standard temperature is 273 Kelvin. That means to be able to convert between Celsius to Kelvin and Kelvin to Celsius, you must come in contact with the number 273. So for me to be able to change from 20 Kelvin into Celsius, I will just add add that 200 to the standard temperature. The standard temperature is 273 Kelvin. So that will become 20 plus 273 Kelvin, and that will become 293 degrees Celsius. And that is just it. And the answer is just 293 degrees Celsius. So don't forget that the standard temperature for all measurements, if you are changing for all temperature, is 273 Kelvin. So if I'm changing from Kelvin to Celsius, just plus 20 to 273, and that will give me 293 degrees Celsius. But if I'm changing back, just minus from this 293 minus 273 Kelvin, and that will give you 20 Kelvin, okay, as your answer. And that is the answer for number 19. Number 20, a glass bottle of initial volume 2 times 10 power 4 centimeter cube is heated from 20 degrees Celsius to 50 degrees Celsius. If the linear resistivity of glass is 9 times 10 per minus 6 Kelvin per Kelvin, the volume of the bottle at 50 degrees Celsius is what? Now, this is a linear expansivity question. Do you remember the formula? Now, anything linear expansivity is given by this formula, you know. Y, that Y is linear expansivity, equals change in what? Change in volume. Now, actually, at a closer look, the question is not a linear expansivity question. Do you know how I know? Now, looking at this now, look at this. They mention volume. They didn't mention length. If it is linear, they will be mentioning length. But they didn't mention length, they mention volume. Then find the volume. You are finding volume, you are coming from volume to find volume. And you were giving temperature, and you were giving, but you were giving linear expansivity, right? Now, this symbol Y is not actually linear expansivity, it is volume expansivity. V2 minus V1 over V1 times change in temperature, okay? Now, but where is my volume expansivity? This is not volume expansivity, this is linear expansivity. That means you were not given the volume expansivity, right? But what will you put in? You have to find the final V, that's the V2. Okay, but how will you find the V2 when you are not given the volume expansivity? Now, actually, what you should do is that if you have been given the linear expansivity, just times it by 3. 3 of linear expansivity is volume expansivity. 3 of linear expansivity is volume expansivity, just as 2 of linear expansivity is the area expansivity. So the person who said this question knew that he has given you the volume expansivity when he gave you the linear expansivity. It is just a little trick. So multiply the linear expansivity by 3, and that is what I was doing here. Okay, that's my volume expansivity. Then I'm to find V2, that's the second volume. But I was given the first volume, right? So what I did first was that I made that V2 that I'm looking for as the subject of formula. And this is where you need to know the mass called subject of formula, because when it comes to expansivity, you will need to manipulate formula many times. Now, if you are not good with subject of formula, you might have a little difficulty here. But now, just follow me. The first thing to do is to cross multiply. V2 minus V1 equals V2 minus V1 equals 3 times all this. So 3 will come here, and that will come 3 linear expansivity times volume 1 bracket temperature 2 minus temperature 1. Okay, now the next thing is to jump this minus V1 from here to this side. That will now become, it will leave from here and come here, so that V2 will be the subject. So V2 is therefore going to become 3 times linear expansivity times V1 bracket temperature 2 minus temperature 1, okay, plus the V1 that came from here. It now become plus V1, because it was negative here, it will become positive here. And that is the formula to use for this question. So now, because here you have now made the V2 the subject of formula. So V2 equals 3 bracket 9 times 10 to the power minus 6 times 2 times 10 to the power 4 bracket, then bracket open 50 minus 20 plus 2 times 10 to the power 4. Okay, and that came from the parameters that I have there. I just substituted them to the other side. So now I have solving for that. Bring the numbers together. 3, 9, 2, and 50 minus 20 is 30. So I'll just multiply the numbers. This. Please multiply them carefully, no error. So that will give me these are the numbers. Then the powers of 10. 10 to the power 6 minus 6, times 10 to the power 4. And that will give me 10 to the power minus 6 plus 4. Okay. Now, but notice I didn't do this other side of plus. You must first begin with this side, multiply all of them, then you now come to this side. Okay. And that gave me, if I multiply the normal numbers, the ordinary numbers, I'll get 1620 times 10 to the power minus 6 plus 4 is 10 to the power minus 2 plus 2 times 10 to the power 4. Then break it down into decimal. This times this will give you 16.2. Then 2 times 10 to the power 4 will give you 20,000. Okay. Then if you plus them, you'll be getting 20,000 16.2 centimeter, and that is the answer, making option D the correct answer. And that brings us to the end of this video. Don't forget that if you learn something from this series, I want to join and to get more content that will better help you understand physics. Click on like button, and I'll get to reach you with more content that will better help you understand. Until we see again, guys, take care of yourself and bye for now.